go. All right, good morning, everybody, and thank you. Sorry for that. The Windows gremlin hit my laptop this morning. Let's get going. Right, this morning we're going to be discussing cybersecurity, and we'll be discussing the first steps into OT intrusion prevention or multi-laying of your cyber network. So this was the original presentation I did, and we'll touch on what is cybersecurity. We're not going to be talking about the IEC 62443-4-2 review in this presentation, as time is not on our side. I did do a presentation on this before, and if you'd like to have more information around this, please give me a shout, and we can always get you guys to show you about that technology also on securing your device level protection. We will be discussing NGFW, so as new generation firewalls, and we will be going through the basis of cybersecurity and then discussing IPS and IDS. Let's get going. All right, so today we all understand that OT and IT are having to join somewhere along the line. We are talking about network conversions, which basically means your OT network, basically your SCADAs, your PLCs, your VSDs, your remote IO running in your plant level environment, and your IT guys, which is your mail servers, your file servers, email systems. They are definitely having to interact more and more today. Because they're interacting more and more, you understand that the risk becomes higher and higher. So as the risk to your OT network as well as your IT network starts to join. And so straight away, what we start looking at is no problem. We start putting in some firewalls, some prevention like that over here. In some companies, they don't even have firewalls that we picked up. They just have a flat network, and OT and IT sort of share the same infrastructure. And today we'll be looking at the difference and why we should be definitely separating your networks, as well as what you can do to prevent a cybersecurity attack and threats across the two different environments. All right, so some common cybersecurity terms. So the first concept we look at is defense in depth. All right, so defense in depth, and we'll do that in a minute, when we discuss that. Also, defense mechanisms. So what can you put in place to defend yourself today? So there are stuff like firewalls, IDS devices, and IPS devices, which we'll be looking at today in bigger details. Threats. What threats are there? One, obviously, malware. I think malware is very well researched. Recently, you all know that Garmin was hit by some malware and ransomware. And for approximately 2 to 3 weeks, Garmin was completely down. You couldn't update any of your Garmin information. A great inconvenience for everybody. But they were asked, I think they were asked for $10 million US. They were asked to release their files. I don't know what happened there, how they released, if they had to pay or not. It hasn't been disclosed to anybody. But that was definitely an issue that has happened, and that was someone. And it happens. It's going to happen more and more, and it is happening more and more in the world today. Ransomware, I think you guys it's well known, and of course DOS, denial of service. As when you have an attack on your system and denies you of actually using your own network, the network is so busy trying to reduce and dump data. All right, what is defense in depth? So on my right-hand side, there is a treasure trove of gold, something that a thief wants to get to. This could be your data, this could be your servers, this could be emails, it could be the hack we had recently where I don't know how many millions of South Africans' information was leaked through one of our companies that look after your information for the banks, one of the large institutions that look after information, and they were hacked, or they were actually sent information to to a person. So the thief on the one side, and of course your information on the other side. So of course we put in multiple layers to protect your information or protect the gold or your well, today information is money. I'll tell you, people tell you information is money. So your information, which is the thieves would like to get hold of. And you can see, you don't just put up a gate and some cameras. You don't just have a security guard with a dog. You don't just have a firewall. You don't just have traps. You have multiple layers so that when somebody's attacking you, you have to go through multiple different steps to get to your information that you're trying to protect against these kind of guys. I was in a webinar recently on Poppy, and they're saying that the average company, large American company, it takes them approximately today something like 7 months, I believe, before they even know they've been hacked. 7 months before you know you've been hacked. So then it takes a further 12 months to get the full security up to date again and prevented. All right. So here are some terms that we look at when you talk about cyber security or network security infrastructure. One, we speak about the outer layer. So the outer layer is the layer that the outside world can get to. This layer is known as the site layer. So site. Okay, so remember this word we're talking about? Site. The next layer is zone. So we look at site, outside world, start moving into the organization, we start zoning our environment. From there, we look at cell. So these are the three terminology we use when we look at security and network security and creating different walls, different protections against a major attack or attack on your infrastructure, so that they don't get there. You can't just go from site straight to your PLC, for example. All right, there needs to be different barriers preventing the thief or the hacker of going straight and destroying your infrastructure, your important infrastructure. And this could be used via firewalling, isolating unwanted traffic. You can start using stuff like VPN or secure VPN or IPsec for securing VPN, okay, right? Protect against DOS attacks, so protection. This is what we do to prevent all of this happening. This is the terminology we use in cyber security or in security. All right, but today we are to discuss something called the NGWF, Next Generation Firewall. And how does this work? How does the Next Generation Firewall work? So if we look at a security network or a network, okay, today, on my left of the presentation, this is the IEC 6244-3 network security. It is securing your device. In other words, making your device more secure. This is firmware that runs on the latest hardware in the world that makes the device more secure. Example, is your password still password? Is a password Moxa, for example, okay, right? Or is your password user a longer username as per your IT environment? And is the password more encrypted? Can you use capitals, numbers, characters in your password? This is what that does, all right? And there's more stuff around it, by the way, but that is that part of it. We're not discussing that today. We're discussing on the right-hand side, cyber security, all right? Let's continue. So this is what has happened in cyber attacks, okay, for OT networks. Understand this. This is attacks that have been created to attack our OT networks. There's not attacks to attack your file server at for your email, for example, in your IT network. This was targeted attacks on your OT network, on your PLCs, for example, on your SCADA systems, for example. And one of the last ones we can see over here was Locker Gotcha. And I think WannaCry is still around today. There's still WannaCry around, running around today still. And of course, there's still more coming. There's still lots and lots of cyber attacks that will be coming through over the next years. It's not going to go away, as we all know. And we have to be ready for the next attack on your system. All right. Here are some documented attacks that have happened over the years. So Stuxnet, we understand, that was an attack on a Siemens hardware in a plant. And you can see the different attacks and what it has cost the economy and the countries. Here's an attack where we actually lost a power station and the whole country went into blackout. But today we're going to have, and thank you very much for TSMC, they actually allowed us and they documented their attack. And they've given us the opportunity to actually discuss it worldwide as what happened to them. It cost them $160 million US. It's a semiconductor company that was hit with ransomware called WannaCry. So let's look what happened over here. All right, so here we go. This is what we look at when we have a typical network. We have our external firewalls from the internet that gives you access to the plant, via VPN, etc. Then we have, and that's your IT network, your business network. Then going down to your control network, obviously then have another firewall. Well, there we go, guys. This has protected them, and they thought they were protected. This is typically what we find today. This is what people say to us, oh no, but we are protected. We have a firewall between us and IT, and we have a firewall between us and OT. Well, let's see if this actually helped them or not. As you know, it didn't help them. What happened there, they had an infected laptop come onto the network. Somebody going to work on the control network, which meant they bypassed both firewalls. Goodbye. No firewall helped them at all. No firewall. What amazes me today still, at a large install base, our large companies, that they still allow third-party laptops to join their network without being vetted first. Crazy, crazy. So this laptop was infected, and it came onto the network, and straight away the malware ran on the network and started infecting their machines. So attacking their machines. As you can see, there was no protection at all, even to the outside world. They're able to bypass their full firewalls. What happened next? The malware ran another task on encrypted files, and straight away, all their files started to become encrypted. And that brought the entire production line down. They couldn't run any more production on the production line. So the fallacy that firewalls can help you will prevent attacks is not true. Today still, some of the biggest risks to networks is the simple USB stick. Still one of the biggest risks, and still not been addressed. Great. I think we'll continue over here. So, learning from this. No device was hardening. Okay. No process was managed. Firewalls did not help them. A zero trust network is what we are actually looking at. Zero trust network is what we should be looking at when you look at your OT and IT network. All right. So let's look at the cybersecurity around signature-based cybersecurity. So yeah, you can see this. By the way, data is still ones and noughts today, by the way. So it's quite simple programming, ones and noughts. I always tell my programmers this. And what happens is that a signature-based encryption looks at the different packets going through the network and verifies if the packet is correct. If a virus is inserted onto the network, we should be doing deep packet inspection and looking at a match, a signature match of a virus. So every virus that's out there has a signature on it. These are the CSV files, and you see later on the files that once a virus is found and it's documented, there's a file for it that tells the antiviruses about the matching in the file. Let's look at scanning applications. So when we look at the next generation of firewalls, we have to not only just look at the physical data, we have to actually look at the protocol and the function it's doing. The function, is it a read, is it a write, is it a reset value? What's actually happening and what is the protocol going through? The next are the actual intrusion prevention and virus virtual patching. So as you can see on the left-hand side, ICSA-19-07, etc., etc., etc. These are the known viruses, the known malwares. This is documented and is a known signature. This is what you update, by the way, when you're updating your antiviruses. These are the files that are updated in antivirus, okay? The known signatures of viruses. The next is where is it coming from? The device identification, the vendor number, the ID, the MAC address, where is it coming from? All right, and then of course, machine learning, the type of connection, the frequency of it, what has changed in the packet. Basically, is an attack occurring? For example, is there a DOC attack occurring? And this has to be fully scanned, every packet, with one pass inspection. And this is done, as you can see for us, in the 500, I think it's nanoseconds over there. Let's see. All right, let's discuss IPS and IDS functionality now and how it actually works. There are 5 key applications when it comes to these technologies. The one is white listing control. We'll go to detail of all these steps over here. The next is worm containment. For me, one of the most important is the virtual patching. I find this very, very a vital part of the next generation of firewalls. Obviously, IPS and IDS at the different modes, and then of course the enhanced OT visualization of the network. Okay, white listing. What is white listing? It's a fine-grained access control to different levels of your information on the network. It looks at the network access, the service, port level, looks at protocol, packet format, and also control commands. It also looks at lowers significantly the possibilities of a DOS attack or an OT Trojan. So you can whitelist read only. You can say, do not allow write, do not allow any other application to run. It also allows you to read, write, or only write to any device, and from where. So if you do have a denial of service, trying to attack and try and write to multiple devices, it will prevent that if you don't allow, if you're only allowing read and you're not allowing write, or if you're only allowing certain information to read and only certain information to write, or certain commands can be written and the rest can only be read. Again, it prevents the attack of your network, and also taking control of it, stop and starting machines, stop and starting of motors, opening and closing of circuit breakers. You know, there's lots of stuff that can be done on an industrial network that can create havoc on your plant. What about worm blocking? So what we do over here is we actually look at blocking the worm at multiple levels. So you might have an infected workstation that, for example, that laptop that came into the network, all right? And you could block it at the point over there, allowing your network then to be safe. But you could also say, well, I'll block every single device, every single system, so that if a laptop does come onto the network by accident, an infected workstation, that all my edge devices will still be protected from a worm. And it will be contained in that infected laptop. So this is, again, a decision to make. How much money have you got to spend? And how secure do you want your OT network to be? All right, virtual patching. This, I think, when I saw this in the product that we launched, for me was probably one of the most important discoveries that we have got. So we all know today that there are probably hundreds of thousands of products that are running on legacy software. For example, Windows 7 or Windows XP. There are still panel PCs. There are still controllers, microcontrollers that are running on Windows CE, for example. All right. And as you know, Microsoft no longer will give you any security updates on Windows 7. This I think happened last year. No longer will they give you any more secure updates. What does that mean for our customers? That means that their computer, their SCADA, their panel PC, their HMI, as running on the plant floor, is now vulnerable to any attack on known viruses or known patches, which Microsoft have done years ago. What you could do with this is put a IPS IDS box, an Ether catch box, in front of that product, of that SCADA, and the Moxa Ether catch will do virtual patching for it, meaning that you do not have to any longer upgrade the SCADA, well, Windows, for example, which you can't anymore. The box in front of it will automatically do the patching for you to the latest cybersecurity patches that the operating system needed. This is also, by the way, the same with PLCs. What they discovered, the researcher discovered, that the average time to repair or do an update on firmware on a PLC, for example, is around 1.5 years. This is the average time it takes for somebody to go and say, by the way, my whatever brand of PLC you're using, there's a new firmware for it, and we need to update the firmware for vulnerabilities of security. Okay, that's now been released. It takes on average 1.5 years. I have got many plants that we know about that will never ever upgrade their firmware. Their statement is very clear: if it works, leave it alone. You know, that's a statement. Don't wake sleeping dogs. So the issue with that is, fair enough, you can leave it, but we understand that attacks are happening more and more, and you'll be vulnerable to it. So what virtual patching does for us is this. Okay, for example, let's say there was an attack after 1 year. There's a known attack that's been launched in the world to attack certain controllers, certain hardware has now been launched. You're vulnerable for that period of time, exposed period, till the time you will update your firmware. If you update the firmware, it might even be longer. It depends on when this vulnerability has occurred or when the virus happens. With virtual patching, we will patch continuously and forever. So no matter when that virus is leaked into the world, your exposure is very, very short. It's basically the time between the virus being released and we being able to find the virus, repair, get a patch for the virus, and patching it into the box. That is the time it takes. And that could be very, very short. All right. Let's talk about the two different modes of protection. So it's IPS and IDS. So IDS stands for detection, intrusion detection, where IPS stands for intrusion protection, and IDS stands for intrusion detection. All right. One is a passive system and one is a active system. If you look at detection on my left-hand side, what we look at there is being able to put a ether catch onto the network and just to see, is there anything happening to the network? Is there anything strange occurring on the network? Am I having a worm running around? Is there someone trying to have abnormal protocols running for no reason? That only runs in detection and monitoring mode. And a lot of customers will go to detection first and say, okay, we understand the network's actually fine, we're having no attacks, but we can then take the same device and move it into protection mode. So now we do detection and blocking, dumping of attacks physically onto on the network. So you could start initially with detection only and then move from detection to prevention. With the same device, by the way, we don't have a different device, it's the same device. But there's different ways of doing it. So you can see on the left-hand side, you have inline, in other words, actually doing protection, and you have your normal network switches, and you have all your ether catches sitting at your vulnerable points in the network doing inline protection. You can have it offline, where you're just looking at the network saying, hey, how's it going? Is it okay? Is it not okay? We spoke earlier on about the three terminologies around the site, the zone, and the cell. So what products go where? How should we position which product? So let's first look at cell. Right, this is at the machine, at the PLC, in front of the HMI. So you divide into cells first. So look at your network, divide into cells. And in cells, we look at a cell protector, which is the ether catch, the ECG102. That sits at cell level. Going higher up, we then start doing zoning. So you have a zone, part of your plant, another part of the plant. Create your zones in your plants. Again, you're trying to prevent an attack of bringing down the entire network. Look at your zoning now. From there, we look at our next generation firewall. That's known as the Ether Fire. And of course, around this, how do you continuously monitor your network for vulnerabilities? And how do you do all those patches automatically? So for that, you need to have your site protection. This is your SDC, your secure dashboard. And this is your software you use to do the automatic updating of all your devices on the network. This software runs locally on the plant, at the plant on site level, and needs to be able to connect to the internet, obviously via a secure method, either using Ether cache or going through a new generation firewall. I hope I explained clearly that the new generation firewall is not what the existing firewalls are doing. Your existing firewalls, what they're allowing is basically to whitelist you. So they say, if you're allowed to go through the network, allow you onto the network. You see, that's what a firewall does. It blocks certain ports, it opens certain ports, and it allows you to go through. If you're whitelisted, you go through. That is not what we're talking about the next generation. The next generation obviously does the same. It does the whitelisting, it does the VPN, it does the going through the network, but it does deep packet inspection as well. It does the looking at the worms, looking at the vulnerabilities, looking at the attacks at the same time. This is the biggest difference between the existing firewalls, the commercial firewalls, if I can say that, to a next generation firewall at plant level, protecting your devices. And of course, our firewalls are obviously need to protect, we have the normal protection on board, but we're also looking at protecting the OT infrastructure. So we have to have the additional virus protections, the additional signatures that also look at protecting the lower down protection. All right, so how does it all work? You'll see that all the devices, something called secured by Text1. Great news for all of us. Text1 is a joint company, a new company from Moxa and Trend Micro. They created a new company called Text1. Why is this so important? Well, number one, Text1 has over 30 years of cybersecurity knowledge on DIP technology. They are the ones that are doing, they have a massive team of engineers that are finding, decoding, and doing the patches for us. So they are the software patch guys in the background, the security guys. And of course, Moxa, 31 years with OT knowledge. So we are building the hardware. We are doing the OS on the hardware. So we're looking after the robust hardware, and Micro is looking after the physical protection software. Together, this company is called Text1. This is the best of both worlds. I need to explain to you again. It doesn't help if you have a piece of hardware. I'm telling you, by the way, yes, I've got a protection for you. I'm doing IDE, IPS, and IDS, okay, right? But I'm only updating this once, I don't know, once every 6 months. What's it going to help you? You're vulnerable for 6 months plus. We need to have an expert in the field of cybersecurity and an expert in the field in OT security. And we believe these two together is a world winner. And we are excited to bring it to our customers. We're excited to bring it to all our potential new customers as well. All right. So there are 3 different parts to this. A1 is the EtherFire, which is our firewall, latest firewall. Number 2 is our EtherCatch. This is the cell protection, and that goes in front of the cells. And of course, STC, the secure software that you use, that you pay an annual fee, and you pay license for that. Okay, right, that's all the patches done. Let's just look at quickly at the EtherCatch. EtherCatch is an amazing little product, and please you can ask any of our salespeople to help you with it. It gives you network visibility. It gives you the white listing. It gives you virtual patching and in-depth inspection. As you can see, the 2 physical ports on the network have got, it's a gigabit port, so no latency on the network, but as well, it's also got a bypass relay in it. This means if the product has to fail for any reason, okay, the bypass will kick in and you will not lose your PLC. So the product had to fail, which we doubt it will, it's able to bypass. We did this as an additional help to our customers. So we have a LAN bypass to prevent single point of failure. Easy to use, web console, and it's if you buy the Pro version, it's on the fly, upgrades and patterns. Probably the most important part of our discussion is our secure dashboard console. This is the software that runs and monitors the entire network for cybersecurity risks. It's also the software that does the virtual patching. It goes and gets the patches on a continuous basis, sees it updated, and then installs the patches automatically to all your devices for you. I just spoke about all this over here. It gives you the alarming, gives you the logging. By the way, it's also able to integrate into your SOC or SIEM. That's your higher level IT security. So they say we need to also, if your IT guy says, well, we also want to see your vulnerability on network, you're able to give them a log file, say, this is happening on our network. How's that? Yeah, this is what we updated, and these are the vulnerabilities we're having at the moment. So you need to have a 3-layered environment. A you have your cell protection. B, you have your zone protection. And finally, you have to have some software that does the patching for you. Talk to our salespeople about this. There are two different products we have. We have the pro version and the non-pro version. The non-pro version does not come with this software. You have to update it manually yourself. You register on Mox's website, you go get the latest patches, you go down with the USB stick and you physically go to the device, you have to plug it in physically, and then you have to install the latest patches. That could be fine if you got maybe 5 or 6 PLCs. I accept that, all right? But for someone like a Sussel, someone like these large organizations with hundreds of thousands of controllers, how on earth do they do this with a USB stick? They will never do it. It's basically wasting their money by doing it the non-pro. This is why Moxa has brought the pro out. And of course, that gives you the protection that you need. We can now go to Q&A session. I hope you guys can hear me, and I hope I can hear you guys. And sure, let me stop sharing, and you guys can take over again.
Great, thanks very much, Rob. That was really, really interesting. I'm hoping you can hear me. Are you able to?
I don't know why I can't hear you. It's actually worrying me now.
Okay, so we're going to go through the questions and answers for those who have sent through already. Thank you very much. And if you do have questions now and would like to send it through via the Q&A button at the bottom of your screen, please do so. We'll also be running a poll while the Q&A is happening, so please give us your feedback there as well. Okay, so...
Sorry guys, it was my volume. My volume was down. That's why I couldn't hear you.
Oh, great. Welcome back, Rob. Great. So we're going to go over to the questions and answers. Rob, the first question is, what is defense in depth?
Okay, so defense in depth means multi-layered network, protection network. So when you say defense, so you're defending, number one, putting your barriers up. In depth, multi-layers. So you do your first protection, your zone is your firewall. Okay, that's the first protection. Then what is next? All right, look at so you first block the first outside, then you block the zones, then you block the cells. So you're doing in depth, not just a flat network, one firewall, and everything is open. That is not defense in depth. That is defense out of depth.
Great, thanks very much. On to the next one. What are 3 common security threats?
3 common, yes. First is you've got malware, you've got ransomware, and you've got denial of service. Are the 3 most common attacks or threats today on networks in general.
Great, thank you. What 3 terms do we use describing secure network infrastructure?
So I think I spoke about quite clearly. The first one is to create the various zoning. So the first is site. Look at your site come in. 2, look at your site. It is cell at the end, and it is zone. So site, zone, cell are the 3 terms we use.
Perfect. What is meant by NGFW?
Next generation firewall.
Great. Can an old generation firewall and router prevent cyber attacks from bringing down your network?
As we showed you guys before, when it came to the semiconductor company, no, it does not help you at all. Not once you've passed into the area.
Okay. TX1 is a partnership between Moxa and?
Trend Micro.
Great. And I see Kenneth also advised us on that. Thanks very much, Kenneth. From Brendan Summers, he'd like to know, is it possible to share cost estimates for the annual subscription?
Yes, we have a full pricing structure for you guys. It is not too complicated, but there are some points. For example, it's an annual subscription per device you have to pay for. And there's also another part where if you're buying a device, let's say you're buying a device now, okay, right? You're not going to pay the full fee till the end of the year. So you're not going to pay another year. You're only going to pay for 6 months, whatever's left on the year, and then you pay for the full year every beginning of every year. Please talk to someone like Brigitte at our offices or your salesperson, and they'll give you the full rundown on the pricing.
Yes, and further to that, if you need to get any contact details, you're welcome to contact our team directly, or you can get in touch with Rob directly as well. Okay, what does containment refer to? Apologies.
So the containment is when the device sees the virus or the worm, it contains it inside there. So it alerts the network. It says to the SES, I picked up a intrusion, prevents it there, contains it at that point, the point of the first ether catch, for example, and then alerts the software, the STC software, that is now detected a virus and it's sitting over here in this container at that point. It also helps you, by the way, detect where is the virus coming into the network as well. And often a problem we find today is that where is the virus coming in from? Where is it coming? Is it coming from the IT network? Is it coming via the OT network? Where is it coming from? So by putting down the ether catch and the firewall, we can actually see at what point where did the actual intrusion start.
Great. And then Zandile would like to know, where can we find these security systems?
From RJ Connect and Moxa.
Yes, so please get in touch, Zandile, with one of our team members or Rob directly, and we'll also be happy to pass those details on. I see Brigitte has also put her email address in the chat, and you can contact her directly for pricing and for the information. All right, sorry.
Go ahead. Last question.
Okay, so the last question that we have, Rob, is how many companies within SA have these products been installed in already?
This is a brand new product. This is the first in the world, people. This is brand new. This is coming hot. We will have other competitors coming through, but we have got competitors that are running firewalls, and we've installed firewalls for many years in this country. So we've got the EDR is a firewall for us, firewall router, okay, right? Whitelisting, etc. But none of them are doing the virtual patching. None of them are doing worm containment, looking at viruses. Everybody else is just looking at the whitelist, yes or no. Understand? Port open, port closed. Route through this way, route through that way. This is not what we're doing over here. What we're doing over here is cyber security. Looking at it's like your cyber security, your laptop, your physical security, you know, your software. This is what we're doing, but we're doing it at the point of PLC level. Do you guys understand that there are known PLC vulnerabilities in the world? For example, on Siemens, on Mitsubishi, there's one that just came out now last week, 2 weeks ago, on Schneider. And actually, not on Schneider, on a whole list of hardware was just released 2 weeks ago, because all the hardware vendors are using a piece of code from the same manufacturers. They all use the same code, installed it onto their hardware, and all those hardware are vulnerable now, all of them. And it's ABB. It's a whole list of them that are vulnerable now at the moment. And of course, no one knows about it, although it's on the national defense in America. So it has to be listed over there. So all those machines are vulnerable now, all of them.
Okay, well, thank you very much, Rob. That's the end of our questions. Thanks to everybody who did contribute with the questions. we are coming to a close. Thank you, Rob, and your team at RJ Connect for...
What I can say is, if you guys would like a demonstration, we have got demonstration products available. We are building a demonstration for you guys to come and actually show you. We come to us or we come to you and actually demonstrate attacks. We have an attack software, and we actually show you how the attacks work and how they actually can bring down your hardware. All right.
Great,
People,
that's fantastic.
Just know something. It is not if you're going to be attacked. It is when you will be attacked. Period. Simple as that. It's not if, it's when. They're going after the bigger guys first. Your turn will come. It's just coming your way. We've been attacked 5 years ago. We had malware coming via an email. It's coming. All right.
Well, to all the attendees, just make sure you're protected. I have posted Brigitte's email address in the chat as well. But again, please feel free to contact us should you need any other further information. And get in touch with the RJ Connect team to ensure that you are protected from all these viruses out there. So that does bring us to a close. Thank you very much to all the attendees, as well as Rob for presenting and the RJ Connect team. Please save the date for our next Africa Automation and Technology Fair Technology Tuesday on the 1st of September at 10 o'clock, where we will have a presentation from Omron. Thanks again and enjoy the rest of your day. See you next week.
Bye-bye.